Hello, so this question is great code, and then given the integer n, you want to return any value n bit sequence. So let's look at. So what it actually means that the requirement is that an integer appears no more than once, and a binary representation of every pairs of adjacent integers differs by exactly 1 bit, and first and last integer different by exactly 1 bit. All right. Anyway. So the idea is you want to make sure the 1 bit, like the bit 1, doesn't have like uh, happens the second time in the return array. So if, for example, 0 1 and 1 0, technically they are considered 1 bit, right? And then difference by 1 bit, pretty true, right? So 0 1 and 1 1. So 0 1 and 1 1 are difference by 1 bit. Right? You only need to change this, right? And then 1 0 to 1 1, you only need to change this. All right, so that's the prompt of the question. So idea is to solve this is you want to iterate the n. So starting from 0 all the way to n, and but not including the n. So you want to make sure how do you append the how do you keep adding a 1 on the right timing. So by default, the return rate is only 0, right? So if I want to traverse, I can starting from index 0, right? So the size of the return array is 0. So if I give 1, so it can be 0 1. So it will initial 0, right? So it can be only 0 1 over 1 0. So the next iteration, I'm going to have my 1 appended. So let's go preprocessors. Preprocess. It was 1, right? So now it becomes a 1 0. So 1 0 is going to be represent 1 1 or the other 1 1, right? So you can go these two paths, right? And then in this solution, the last one you cannot have 0 1 again because you have it, right? You have it in this sequence. In this sequence, you can have 0 1, right? Because you have that 1 0 in the beginning. I mean, on the on the second index. But in this one, you want to update to 1 0 because in this sequence they are all unique. So how do you do this? Is trivial based on the current iteration we have. So if n equals to 3, right? Supposedly this should work. Like we only traverse whatever the current iteration, the value in the return array, and then you can keep appending. And then for the preprocess, this is a trick. You want to keep assign the value for preprocess. So 1 0, like at the first index, you shift left by 0, right? And then at index 1, you shift the 1 by left 1. So it was become 1, now it become 1 0, and then all the way to n, right? But not including. So if there's more, then just keep adding. So based on this, the one are unique, and then the value you concatenate are also unique. That would be the solution. So I'm gonna have the return array, and then I will have to have the initial value, which is 0, and then I'm going to traverse, right? And then I will have a preprocess equal to the 1 shift left by I, and also what's my current size of the resource, so I will be able to add it based on the iteration. So the trick is I want to starting from the last, because you want to know you are changing every single bit by 1. Like every pairs adjacent integer different by 1 bit, right? So you want to know the largest one first, because every single time you add it, is going to be the 1 bit difference from the last index. So j will become the size, and then it has to be -1 because we are dealing with the index 0. And then j greater or equal to 0 and j minus minus, and result.add, it will based on what the last index value. So result.get at j, and then you want to plus the preprocess. So that would be the idea. And then submit. Yeah, so time and space is going to be the worst case. So think about it. So n equal to 2, size is equal to 4, right? And then if n equal to 1, size is 2, so it's the power of 2, right? So it's 2 to the n for the space, and then 2 to the n for the time. So that would be the solution. And then if you could look at like whatever the author given the solution, you can be able to understand easily. But it would be too much for this video. Alright, see you later, bye.